let's continue practicing to draw Lewis structures. We're going to look at structures now that involve just hydrogen and fluorine atoms and one other atom. So for example, H3O plus, you have oxygen and 3 hydrogens here, or OF2, you have an oxygen and 2 fluorines. Whenever you have hydrogen or fluorine atoms, okay, these atoms can only form each of these atoms can only form a single bond. So we say these atoms are univalent. If you remember, hydrogen has just one electron, one dot, right? To become isoelectronic with a noble gas, it follows the duet rule. It just shares that one electron with another atom, so now it would appear to have a duet around it. Now fluorine, if you recall, right here is in group 7A. It should have 7 valence electrons, so you can represent it with the atom can be represented by F with 7 dots around it. And again, we can see that it only needs one more electron to become isoelectronic with a noble gas, which is neon. So in order to acquire an octet, it just needs to share that one electron that it has with another atom, and it's happy. So now this fluorine right here has three lone pairs and a single bond. Okay, that basically means that hydrogen and fluorine atoms, if you have them in a molecule, they have to be terminal atoms. They have to be connected to just one other atom. So they have to be at the edge of the molecule. All right, so let's look at H3O plus. How are we going to draw the structure of H3O plus? Well, okay, all of these are going to be terminal. So let's start with just the oxygen. And now we've only got the hydrogen to attach, so I have to attach a hydrogen to the oxygen. The other hydrogen also needs to attach to the oxygen. Okay, you cannot attach a hydrogen to another hydrogen here because this will give you 2 bonds around that hydrogen. So that's wrong. Okay, so that's not correct. So the third hydrogen has to go again attached to another. Attach again to the oxygen. So you connect the 3 hydrogens to the oxygen, okay, and then let's figure out how many electrons we need to show. Okay, each hydrogen contributes 1. You've got 3 of those times 3, and the oxygen belongs to group 6A, so it contributes 6 valence electrons. That's 9. Okay. 9 valence electrons that you need to show, but you have a +1 charge, so -1. A +1 charge means 1 less electrons. You need 8 electrons to show. So far, we're showing 2, 4, 6 electrons around the oxygen, and if we try to follow the octet rule, we need 1 more pair of electron on the oxygen. We can do that by adding a lone pair to the oxygen. So I'm going to put a lone pair right there. And let's examine the structure. If you look at the structure, you have 2, 4, 6, 8 valence electrons shown, which is correct, which is the number that we need. So that's good. But there's one more thing we need to do, because this is a polyatomic ion. It has a charge of +1. We have to enclose this whole thing in brackets and put a +1 on the outside. So that would be the Lewis structure for H3O plus, which is also known as the hydronium ion. Okay. Now let's do OF2. OF2, again, your fluorine has to attach itself to an oxygen, and the other fluorine also attaches itself to an oxygen. You can't attach a fluorine to a fluorine, because then neither one of these can attach to the oxygen, because both of them already have 1 bond. Okay, so you can't do FFO. That's not going to work. Okay, so you can do FF. That would be F2. That's you have an F2 molecule, a diatomic molecule. You can draw the structure for that one easily. So you have to put the oxygen between the 2 fluorines. So now let's see. Fluorine contributes 7 times 2. That's 14. Remember, fluorine belongs to group 7A. And oxygen contributes 6, so that's a total of 20 that you need to show. Well, let's follow the octet rule. Let's give fluorine its octet. So you have, okay, the bond makes 2, so you need 3 lone pairs, 2, 4, 6, 8. The other fluorine needs three more lone pairs. Okay, so you have 2, 4, 6, 8. You have an octet around the fluorine. Okay, and this fluorine over here has 2, 4, 6, 8. So that fluorine has an octet. Okay. And the fluorines are happy. So now let's look at the oxygen. How many electrons do we need for the oxygen? Well, oxygen currently has 2, 4, so it needs 4 more. So 2 more pairs. I can put that in as lone pairs. So 6 and then 8. Alright, so that is OF2. Let's verify that we in fact have 20 valence electrons there. You have here's a quick way to count. An octet here and an octet here, so that's 8 and 8, and then you got 2 lone pairs here, so that's 4. So 8 plus 4 plus 8 gives you a total of 20 valence electrons. So OF2 has this Lewis structure.